All right, let's try and finish up this study guide with 4 and 5. For each of the following statistics, indicate which are sensitive to outliers and extreme values, or will they dramatically change? So let's start with just running a little test. I'm going to give you you can go ahead, anything right there. I'm going to give you a basic number set, one that even my toddlers could come up with. 1, 2, 3, 4, 5. Get some basic stats. Basic stats right there. All right, so 1, 2, 3, 4, 5. Our mean is 3. Standard deviation is 1.4. Median 3, and our IQR 4.5 to 1.5 is still 3. All right, now what happens if I throw in an outlier into the mix? Previously, we had a 5. Now look at, let's say something like 50. 50 should definitely be an outlier from the number set 1, 2, 3, 4, 5. And let's compare some things. Our mean went from 3 to 10.8, which is almost 11. So you could definitely say that the mean dramatically increased. So we call it sensitive to outliers. Get rid of that. We don't need to see. All right. So mean was sensitive to outliers. Look down here. Our old standard deviation was like 10. Now it jacked up. I'm sorry, it wasn't 10. It was like 1.4. Now it jacked up to 17.5, almost 18. You'll definitely say standard deviation is also sensitive to outliers. Now our median was 3 and our IQR was also 3 before. Look at it now. Median went from 3 to 3.5, so it's not much different. And our IQR is 5 minus 2, still 3. So you'd say IQR is the same and median is mostly the same. So you can know that standard deviation and mean are generally sensitive to outliers. They're not really affected, as opposed to mean and standard deviation are dramatically changed. They are sensitive to outliers. Median and IQR are generally not affected. Number 5, the following histogram displays the win totals for the White Sox over the last 16 years. Describe the shape of the distribution. It looks a little bit skewed. It looks like there's a little bit of a tail going on here, with most of the data right in that 85 to 90 win stuff. So I'd say probably skew left. Skew left is a better answer because you see it tail off a little bit. Comment on the position of the mean relative to the position of the median. Remember that your mean gets pulled into the tail. So we would say that the mean is on the low end, so that the mean is less than the median, which is going to be closer to the hump right here. So that's what you would say. And just as a little bit extra, because that's how I roll, remember, if you're reporting a skew diagram, your center should be reported as whatever the median is, and use the mean if it's a symmetric diagram. And if you're talking about spread, report your IQR. 6 is just asking, do you really know what variability means? For a study, Jay had to weigh every member of the football team versus Aaron, who had access to the weights of everybody at the school in Power School. Who sees greater variability? What's going to be more spread out? What is going to be more spread out? And it definitely should be the weights of everybody as opposed to just the football team. You'll expect a lot more heavier people in the football team than the weights of everybody at the school. So variability, you should definitely think everyone. All right, good luck studying.